Hello and welcome to another tutorial. So this time around we are going to be extending the terrain helper and we're going to be adding to it a feature that folks have asked for a bunch, which is being able to convert a terrain into a low poly mesh. So what we're going to do is we're going to set up so that it will take an existing terrain, it will convert that into a mesh, generate a prefab for that, and also take essentially a photo of the terrain and generate a texture for that. And just as a additional thing for completion, it will then spawn it into the world so we can easily see it overlapping on top of it. So let's dive on in. So what I've already done is I have already added in some textures to this, and I've also then applied them to the terrain, and I've specifically put a couple of markers here in the corners, basically so that I can make sure I've got the rotation of it correct, because that's something where I want to make it that for this to be useful, it needs to be a case of cool. You can just drop it in exactly where an existing terrain is. I don't want folks to have to reposition things or anything like that. So that's really important with it. So let's dive on into the code and let's get started with what we need to do for this. So there's a few different aspects to this. One of the things, I'll get rid of a redundant using there. So let's set up firstly just the actual initial bits for being able to show the particular tool. So what I'm going to do is similar to what we've got here, and I'm actually going to grab the sections for the export, which that's exporting the height map. So what this is going to be is this is going to be our terrain tool. And this is going to be convert to mesh. I don't have this Boolean set up yet, but that's okay. And this will be convert to mesh. And we just update the text here. So just want to get the interface going for it actually running. So this will still be generating a bunch of errors. That's okay. So, okay. So far, so good. We'll set up that Boolean. We'll also set up the logic in our reset here. So that's good. So now I can start to set up this function. Now there's quite a bit that this function is going to need to do. There's quite a bit that it's going to need to do. So we'll have our convert to mesh. It, same as the other ones, takes in a target terrain. So there's a few steps to converting something over to a mesh. We need to generate the vertices for it. We need to convert those vertices and store them in a mesh. We need to generate UV coordinates so we can texture it. Then we need to also generate that texture, create the material for it. So there's a lot of different stages to this that I'm going to need to set up. What I'm going to do initially is I'm going to get the actual mesh generation happening, because that's a pretty crucial part. So a couple of things I'm going to do with this. One of the things is I'm going to just save out the height map resolution. And that's going to be that. So we're going to just save that out. Then I'm going to be retrieving the heights. And this is going to be our 2D array. So that we can go, okay, target terrain, terrain data, and get heights. And we need to tell it the section to get, which is essentially we're grabbing the entire terrain. So we want to get the full set of heights for that. So that actually switching between C# and C++, it's one of the things that happens there is your array indicators switch sides, so inevitably I end up takes a little moment to adjust. So okay, for a mesh there is a couple of key things that we need to generate. One is going to be the vertices, so those will be a vector 3 array. So vertices, and we know how many we'll have. That's going to be vector 3 height map resolution by height map resolution, because each entry in the height map corresponds to a vertex. We're going to have our UV coordinates, which every vertex gets a UV coordinate. Those are only a vector 2, but just like with the vertices, we have that full amount of them. So then our mesh is made up of triangles. So the way it works is you provide a bunch of vertices and UV coordinates, and then you define the triangles, and the triangles are actually an integer array. And the triangles indicate, okay, the vertex at this index and this one make up a triangle. So what we're going to have is the triangle indices is a new int. Now, this one, we actually have a different number of ones. Now, yes, we do have height map resolution by height map resolution is the basis of it, but we have 3 indices to make up a triangle. So we actually need times 3. And we actually, to make up a quad, we have 2. So times by 2. Now, we have, say, 10 vertices across. That's not 10 pairs of triangles, that's actually 9. So we actually have height map resolution minus 1 by height map resolution minus 1. It's not a problem if you allocate more indices than needed, but we generally want to try and only allocate the exact amount that we need. So, okay, now I can actually generate that mesh data. So we have fairly, what we've written many times before now for iterating through the data. Y is 0, Y is less than height map resolution, like that. Then we do the exact same thing with X. So we have our exact same setup there, like that. Now, okay, we need to know the index that we're storing things at, our vertex index. So that's easy enough to store. That's going to be X plus Y times our height map resolution. So that's good. Now we need to be starting to store things like our vertices and UV coordinates, things like that. So UV coordinate is actually pretty straightforward. Our UV coordinate is going to be, so at vert index is a new vector 2, and we're going to have that be a float of our X coordinate divided by height map resolution minus 1. And then we do the exact same thing with Y. And I'll put that on another line just so it's a little bit clearer, but I'll also make sure I do the casting to float. The reason I'm doing the casting to float here is if I didn't, I would have integer by integer division only, if I just had x divided by height map resolution minus 1. So doing float and also the 1f here, I really only need to do one of those, but I'm just doing both for safety. If I didn't have that, it would be doing an integer division, and because x is always less than height map resolution until the very last one, we would end up having it be 0, except a thin band of 1 at the edge, because when you do an integer division, it always is going to be a value that is truncated. It loses the decimal places. So this is just to ensure we retain that. So now for the vertex position, what I'm going to do is vertices, vert index is a new vector 3. Now what I can do for this is then going to be firstly our x position, which is going to be x times by target terrain, terrain data, height map scale dot x. Then we need our height. So in this case, we would have our heights, and we grab yx multiplied again by the height map scale dot y. And then we do y times by dot z. So our height map scale dot z. That will give us our location. So it ends up being a little bit messy. We've got a few different things we're having to be scaling by the height map scale. But essentially we're taking our vertex coordinate, scaling it by that location, or that scaling factor, to get our actual position. So that looks good. We're generating our vertices, we're generating our UV coordinate. We now want to generate the triangles, but we don't want to do that for the very last either row or column, because if we remember, we're iterating over vertices here, and the lower left vertex has 2 triangles for it, but for example, the upper right one has none. It's part of ones that are to the lower left of it, but there's none above it or to the right. So what we want to do is we want to check if x is less than height map resolution minus 1 and y is also less than height map resolution minus 1. If that's the case, then we can store these indices. So what this ends up looking like, roughly, is we have vertex index, and generally the way that I write stuff like this, so it's multiplied by 6 because we're generating 2 triangles at a time, which means we're generating 6 indices at a time. So our offset location is always going to be the vertex index multiplied by 6. So then what I generally do with this is I'll have ones that are like +0, and we'll go vert index. Now this is our base version. And then what I'm going to do is set up for all 6 that we generate. And we have our 2, 3, 4, and 5. So this will define one triangle, and this will define the second triangle. Now, the order that we do these in does matter, because essentially whether some rendering process is going to be set up to either decide that clockwise or counterclockwise is how you can use to determine which is the front-facing side of a triangle. So if we get this wrong, parts of the mesh won't be visible when we're looking at them from the top, but they might be visible when we're looking from underneath. So getting the setup of this right, getting the winding correct, is important. Which is why I always, when I'm setting these up, go and refer to stuff that I've previously written where I've worked out the winding, so that I save myself having to figure it out again. In this case, I've already figured out the winding, so that's sorted out already for you. So, okay, we've generated the vertices, we've generated the UV coordinates, we've generated our triangle indices. That's actually the majority of what we need. Now I can actually create our mesh asset. Create the mesh asset. So what I do is generated mesh is a new mesh. Now I need to set its index format. And what I need to do is I need to check the number of indices that I have. So if triangle indices length is greater than uint 16, I believe it is, we might have to do system.uint16. Yep, we do. Max value. So if the number of indices is above that, then we set our index format to 32-bit, otherwise 16-bit. So that's the first thing we need to do before we actually set any of the things. Now we will set over the triangles and the vertices, and what I'll actually do is I'll use set UVs, channel 0, UV coordinates. I will also do a set vertices, and do the same thing for this where I'm setting the triangles. I could still use those direct access properties. I just prefer, because I think it conveys clearer what you're doing, using the actual sort of set functions for this. So, okay, we've provided all of the data, we've set the index format. We can now tell the mesh to recalculate its bounds. It's important for if you're then using it for collision, things like that. And also we want to recalculate the normals. So, okay, I've generated the mesh asset. It's got everything it needs there. What I haven't done is I haven't saved that mesh asset. So that's something where I can save it at the moment. And what I would do before I start doing any of this is I'm going to actually store our base asset name. And that's going to be target terrain name. And what I'm also going to then do is store out the scene path. So what I will do is system.io path, and I want to get directory name. Or if I go for the scene manager, and get active scene path, like that. So just a couple of key things I want to have there. So I've generated the mesh. I haven't saved the mesh asset yet. So then I want to save the mesh asset. So what I would do for saving this is, firstly, let's construct a path for it. And so we use our path combine. And I'm going to say that it'll be at scene path. And we'll call it base asset name mesh dot asset. The extension does matter with these, and you do need to make sure you get the extension right. Now we want to make sure that that's a unique name. So what I can do is I can ask the asset database to generate a unique asset path with that. So just make sure I've got a reliably unique name there for it. Then I can go asset database, create asset. We give it the generated mesh and the mesh path. And then I tell it to save the assets. So that will have created and saved the mesh there. So we can test that out and see how that works. So select our terrain. So we'll make sure we've got the scenes folder selected. So we'll do convert. So we did get an out of range one. And if we take a look, it's actually from these indices. So we actually do need to be generating the full set of ones there. I always get mixed up with which ones I need -1 for and which ones I don't. But with that, we should now be able to generate that mesh. And we'll make sure we've cleared, sort of converted, so we can see we have our mesh asset, and we can see it does line up perfectly with it. It doesn't have any texture or anything like that yet, but it does line up with it. So that's good. Now what we can do is we can actually start to capture things like the texture for it. Now, for capturing the texture, what we're going to need to do is we're going to need to set up a camera above the terrain pointed down at it, and we're going to need to position it so that it captures the full terrain, and then we can force a render, capture that texture, and then save that asset as well. So what I'm going to do is I'm going to first set up our capture camera, essentially. So set up the texture, the camera. So what I do is game object, texture, capture, game object. Here's a new game object, and we'll call that capture camera. Now we will delete this after we've created it and we're done with it, but for now what we want to do is set its parent firstly to our target terrain transform. Then we want to adjust its position. So its position should be a new vector 3. Now to make it positioned exactly in the center, what we want to do is target terrain, terrain data, and we use size in this case. So size.x, and we divide that by 2. We then do for height, we actually just use the full size. So size.y. We want to be a little bit above it, and in particular we want to make sure our camera's clipping plane, its near clipping plane is above it. So I'm actually going to add a little bit to that. And the Z coordinate just follows exactly what we did with the X. So that will position the camera. Now we need to tilt the camera so it's actually facing down. So what we want to do is, this is a good case for using Euler angles. So let's set our local Euler angles to a new vector 3, and we use 90, 0, and 0. That will give us a camera that is rotated the correct way, and in particular is pointing down at the actual object, the terrain itself. So that's good. We've set up the game object for it. Now we can set up the camera. So our capture camera is our texture game object, and we add component camera. Now we need to configure this. So a couple of key things that we need to do. So the clear flags is going to be solid color. I'm going to set it so that the color is jet black. I'm going to also then, we need to make it orthographic, because that way then we don't get any perspective distortion, things like that. Also, makes positioning the camera really easy, because the camera size, so the orthographic size, is able to just be set to our target terrain, terrain data, size, x divided by 2, like that. That will give us a camera that it fully encompasses the terrain, so that's good. And I'm just going to let the undo system know that I created this object. So I created the texture capture game object. So we just register that we have gone and done that. So, okay, I want to turn off any trees and foliage, things like that on the terrain, but I want to keep the old setting. So, and trees and details it actually is. Trees and foliage is our target terrain. Draw trees and foliage. Then we turn that setting off so that our trees aren't going to get captured as part of the texture. And so we're nearly there. We'll restore this setting later. That. So now what we do is set up our render texture. So we set up our render texture and capture the image. So what I do is I set up our render texture, capture RT as a new render texture. Now we need to give it the size. We want a resolution for this. So what I'm actually going to do is I'm going to come up here and set up a texture resolution, enum like this, and we'll have resolution 512 by 512, which I will make equal to that. And then let's set up a couple of other ones. So we'll have 1024, 2048, 4096. So we'll just update all of these. So this will just allow us to fairly easily control what resolution we want for the texture. It's just a nice little option to make sure that we've got available to us. So that's good. I'll set up so we have that stored here. Texture resolution. And I'll default it to 2048, which again, I'll put that into the reset code up here. So, okay, that's good. We've got the ability for setting that. I'm going to have that be something that gets passed through here, which means that our convert to mesh has a e-texture resolution, like that. And I'll set up the UI for controlling that in a moment. But what this will let me do is have this be something now where it is fully controlled by the user. So we'll say that it's that resolution and 24-bit. So, okay, that's good. We've set up that render texture. We can link the camera to that. So the camera is now, actually that should be target texture. So target texture is our capture one. Then we need to create the actual texture 2D that this will all go into. So this is going to be our terrain texture. I'll actually call this captured texture. And that's going to be a new texture 2D. We could just directly take stuff from the render texture here in terms of the width and height and everything. That'll ensure things are staying consistent. The texture format is RGB24, and we do not want a MIP chain for it. So, okay, we've set up the render texture to capture the image, we've linked it to the camera, we've set up the texture that things are going to go into. Then, what we can do is capture camera render. So we force a render of it. We go and say render texture. Its active one is the capture render texture. And then we are going to read all of the data. So captured texture, read pixels, and we read the entire amount. So it's a new rect from 0 to 0, and we need to provide the width, which we can again use our capture render texture. Oops, that should be rect. That's where we read from, and that's where it gets written to. So that will have read into the render texture, means we can restore this setting now. Means we can clear this. Although it's not strictly necessary, I'm going to do capture camera target texture also goes to null. So this is our cleanup. And because we don't need it anymore, I'm going to destroy immediate, render texture, and our capture camera, texture capture camera game object. So we just fully clean up, we make sure that we don't have any of that still left over. So, okay, save the mesh, we've created the texture. We need to save the texture, which is going to follow a very similar process to this. So we've got this same process that we're going to follow to actually save the texture asset. So we're going to actually bring that down here. So it's almost identical. So save the texture asset. So the texture path. And this is going to be texture, but it's not going to be .asset, it's going to be .png. But we can still make sure that we have created a unique path for it. Now we won't do create asset for this because it's a texture. What we would actually do is do a file, write all bytes, texture path, and we use captured texture encode to PNG. And then we don't need to do a create asset. And then we don't need to do a create asset. And we don't need to do a save, but we will refresh the asset database. So we've actually gone and saved that file. And so that should save out. So let's test and make sure that that's working. So we do have an error there. So good to just fix those straight away. So we'll test. What we want to see is that we actually get a texture appearing here. So runs, and we've got a texture. That texture looks roughly right. So that looks good. And also the temporary things created here are all gone. So, okay, we're getting pretty close to being done with this. We've got our mesh created, and it's creating the asset. We've got our texture created, and we've got that being saved out as an asset. Now we can actually go and properly set up our material and create an actual prefab that then can get spawned in the world. So, I'm going to load the texture asset. Of texture 2D. So the reason I'm doing this is because what we saved out was a version of the data, not the actual specific asset. So I want to be having something that's fully got all of the asset information associated with it. So we have our texture, which we already know the location for it. So we can do an asset database load asset at path, texture 2D like that. So that's good. So we can create the material. So for creating the material, we need to do a similar thing where we go, okay, well, material, terrain material, and we create a new material. Now I'm doing this with the built-in pipeline. The exact name of the shader that you need is going to vary a little bit based upon the pipeline. I'm just using the default one. So you might need to change this for things like the universal or the high def pipeline. The name here will likely be different, but I'm creating that material. And then the terrain material, I want to set the texture. Again, if you're using a different shader, the actual one that you set here might be different. So for the standard one, underscore main text is the texture name that I use. But if you're using a different shader, different pipeline, then that could easily be different. So that's just something to be aware of. So now I need to save the material asset, and it's going to follow, again, similar process to this. Let's save the material. So we just, again, do this same process. This is terrain material. Now we do need to make sure we get the name right. So it has to have the extension MAT. So we've got our name. We're saving out the material, so that's good. So we're getting pretty close now. We've got a mesh. We've got our texture. We've got a material for that texture. We're now able to do the final part of creating the game object that will actually be in the scene that has the mesh and material and everything like that set up on it. So that's going to be the final sort of part that we do for this. So we set up the game object. So game object, terrain game object is a new game object, and what we'll do is we'll call it, and we'll use target terrain dot name and mesh like that, so that we've got the particular name for it. We add the mesh filter. There we go, our terrain game object, and we add that component. We link, so not a new mesh, but our generated mesh gets linked up to that. Then we add a mesh renderer. And again, we're adding that component. Now our mesh renderer, we're going to set materials, and that's just going to be a new list of materials like that. So we're setting the particular material, so that's good so far. I'm going to record a created object undo for this. Do like of that. Now, what we can do is we can generate and save the prefab. So there's a little bit involved in this, but it's not too dissimilar to what we're doing here. So what we will do is save the prefab. So prefab path. And similar process of making sure that it's a unique name, has to have the extension prefab. And we'll go for like that. Actually, we'll just, I think that's fine for the name. So we've got a unique name for it. What I then do is, it's a little bit of a different process for creating it, but we have prefab created is false, and then we go game object, prefab game object is a prefab utility dot save as prefab asset. We give it the terrain game object, the path, and if that prefab was created. Once we're done, we can then check if the prefab was created. Then we have a couple of options here. We've already got that game object in the scene, but what we could do is we could destroy it and then respawn it from that prefab. So we could do a destroy immediate of that terrain game object. And then I will just spawn that in the world. And we can go and say that our prefab utility instantiate prefab. And we have that prefab asset. We give it the no parent because we don't really actually want it to have a parent object. So, we can just give it the asset. We could give it a location, anything like that, but we're just going to spawn it like this. So game object, mesh game object, like that, and then we will just position it. So with this, what we need to do is as game object, just to convert the type there. And we just need to position it now. So mesh game object, transform position is our target terrain, transform position. Because the idea is that this should be able to be positioned exactly at the location. So the rotation, like that. And then we just also register that we created that object. So that should do it. So let's test this out. What we're expecting to see, hopefully, is, and we might have a couple of errors we need. No. So what we're expecting to see is that it will create the prefab and everything like that, spawn it in the world, overlapping with this terrain. So let's test that out. So it's run, spawned it in the world. And we can see we've got our mesh, we've got the material, everything like that. These are linking to the correct assets. And if we toggle the terrain off and on, you can see it's a pretty close overlap with it. So that looks pretty good. So it's added in some extra materials there. So, final thing we want to do, now that we've got that, is I just want to make it so that I can control what the texture resolution is, because that's something where we don't currently have a control for that. So I am just going to steal what I did with the enum one here and bring this down. And this will be our texture resolution. Got that. Just makes it so we've got a little bit more control over it. And we can see, cool, it's 2048. We could go lower res if we wanted, or higher res. So let's run a conversion again. And that all looks pretty good. Now, it's going to be fairly smooth with the resolution we've gone for, but if I turn off the main terrain, and this is where using a different shader you'd be able to get it looking a bit more faceted. This is going to be a much sort of smoother one because of the resolution of the terrain and everything like of that. But if you change the shader, you'd be able to get having that more sort of faceted look. This is just using the default one, so it's obviously going to be a lot smoother. And it matches the terrain, you can see quite closely. So the other thing I could then do is, okay, let's get rid of that, and let's test what happens if I do a conversion again. So that works, and we can see it correctly generates unique names for those assets. So that is excellent. So leave that, and we'll do a final conversion just so we can leave those in the world. But we have our setup going for being able to generate our mesh version of the terrain. And there's further things we could add to this, where it was going and downsampling the resolution of that mesh and making it coarser. That would be a very doable thing that we could easily be adding into it, that we'll add it in the future. We could also be doing stuff where you can select the particular shader that it's actually using. So there's further enhancements there that we could be adding to that. But it gives us a tool now, at least, to be able to easily convert any terrain into our mesh version. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and there is a link to that in the description below. If you are looking for other videos, there is a searchable video archive, and there's a link to that in the description. If you've got any questions, chuck in a comment below. This code is obviously something that you can use in any of your own projects, commercial or non-commercial ones. There's no restrictions there. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description as well. But until next time,